Today we are going to cover the topic runtime environment. Okay. So what is runtime environment? We are going to cover the topic runtime environment. So while program is running, we need to maintain some information in the memory. For example, if you're calling a function or you're passing the parameters, so where the function will return the value, what is the return address of that function, what are the parameters you are passing into the function, these information needs to be put into the proper places, right? So for handling the proper execution of the program, compiler does runtime management. So basically, you write the program of the source language, source code in the form of source code. This source code gets converted into the target code using a compiler. And after this target code, this code converts into the machine level language, right? Now this machine level language program needs to be executed into the needs to be executed, right? So for the execution of a program, you require the runtime environment. You require the runtime environment. Fine. So what are the elements of the runtime environment? So generally, first of all, we need to know what type of memory organization or the storage organization is required. Fine. So in case of memory organization or the storage organization, there are 4 parts which are important to know. So first part is a code part. After that, there is a static or global variable stored into the memory, and then code part is stored into the memory. After that, a static and global part stored into the memory, and then heap part is there, and then at the last stack part is there. So what happens, the code part basically takes the fixed memory, the size of the code is fixed, so it is a fixed part and known at the compile time. The size of the memory is known at the compile time. Similarly, in case of static and global variables, the size of the static variable and the size of the global variable is known at the compile time only, so this area is also fixed. And now before starting the heap area or a stack area, let's discuss about the static and the global variable first of all. What is the static variable? Where the allocation of the variable, where the memory allocation of the variable done at the at the time of starting of the program, and the same memory and the same value, the same initialization it uses for the whole program, right? So in this way, the static variable is the value of the static variable is available till the execution of the program wherever you are going to use the static variable. Same in the case of global variable, the initialization is done at the start and the variable visibility is actually available at the whole program. But in case of a static, the visibility can be global or can be local, but it all depends in which type of block you have declared the static variable, right? While in case of local variable, the visibility is only available where you have visibility will be available where you have declared that particular local variable inside the block. So first of all, we'll see the difference between static and local. Although I'm revising this topic, you have already studied this topic many times while studying the C language, C++ language or Java, but we will need this concept, so I'm revising it again. So suppose I'm writing a function, say fun, and in this function I've declared a variable static int and say a is equal to 0. Fine. And then we are incrementing this variable a is equal to a plus 1, and then we are printing this variable just to know how many time what is the current value of this particular variable. Now if you will call this variable, suppose I have made a main function and I have called this function, say, don't go for the syntaxes or the declaration. I'm just explaining you the concept of static and local variable, right? So I've made a loop, for loop, and in this loop I've called a function fun. So which means according to this loop, your fun function will be called for the 3 times, right? So for the first execution number 1, when you will call the function fun for I is equal to 0, what is going to be printed? A is equal to 1, right? Now for the second call, when your I is equal to 1, because it is a static variable, so initialization won't be done again because the memory and the initialization has been done already. So it will only increase the value which were previously stored, right? So which means you will get the value 2. Actually, what according to logic क्या होना चाहिए था? The value of a needs to be initialized again by 0, but because the nature of the variable is static, so it won't be initialized again. It will be initialized only one time, right? So the for value of I is equal to 2, the value of a will be 3, and after that your loop will be finished. Now let's take the same example with the local variable, right? So now a is local, there is no static specification is there. In this case, if I is equal to 0, a will be reinitialized again. Reinitialized. Uh, a will be initialized first time. So the value of a will be 1. And now the counter is incremented by 1. So I is incremented by 1. So I will become 0, but because a is a local variable, so it will be initialized again. So which means a is now 0 again. So value will be 1 again. Similarly, in case of I is equal to 2, a will be initialized again by 0. And obviously, if it is incremented, so you'll get the value 1 again. So this is the basic difference between the static and the local variable. So I just wanted to refresh the concept of the static and the local variable nature. So what is the basic difference between a static and the local variable? Once the memory is allocated, value is initialized in the static nature variable, value won't be initialized again and memory will not be allocated again, right? While in case of local variable, the memory will be allocated again and the value will be initialized again. So again and again your value will be reinitialized, and according to the function your logic works fine. So the second area that we were discussing about the static and the global area. So now the concept is clear. The value that the memory that you have already allocated once into the program, that will be fixed throughout the program. So it is known at the compile time. Now third area is the heap area. Heap area is basically an area which is used at the time of dynamic memory allocation. We know that we use malloc and calloc for the in case of C language to allocate the memory, right? We use new in C++ or Java to allocate the memory. So basically these are the commands which are used for the dynamic memory allocation, where we have no idea how many memory is required at the compile time. So basically we allocate the memory at the runtime. To refresh the concept, I'm just giving you one syntax of the malloc. Now suppose I have declared a pointer A and I wish to I wish to create an array of n elements, right? Where the value of the n I'll enter at the runtime. So what I have done, I have written a scanf and the value of the n I'll scan. Fine. Now, whatever value I've entered into the n, I wish that A should have those much memory allocation. So I'll allocate the memory to A at the runtime. So what will be the syntax? Because it is a pointer to the integer, so it is a pointer type. Then I will use a function malloc. What should be the size of the one element? So size of the one element should be equals to the type of the data for which you want to create the array. So it is integer, comma, how many multiplied by how many elements you want to create. So I wish to create n elements. I wish to allocate memory for the n elements. So in this manner, you allocate the memory to the pointer A, right? So this type of allocation is called as the dynamic memory allocation, and it is done inside the heap, right? It is done inside the heap area. Okay. Now the fourth area and the last area, last storage allocation is stack. So stack, as we know that it follows the concept of last in first out data structure. So whenever you require any concept which applies last in first out technique, so the execution environment takes the memory area that is called as a stack. Now let's take one example. Suppose there is a function. You have declared the recursive function, right? Recursive function. Now what happens in the recursive function? The function call itself. So what is the meaning of that? You have declared a function and the function is calling itself for the next value execution. So we'll take the simplest function. Suppose there is a function factorial to calculate the factorial and passing a parameter n inside it, right? So what is going to happen if the value of n is equal to 1? So obviously the factorial will be 1 in this case, right? But else, if the value of n is greater than 1, then what am I going to do? N multiplied by, I'll call factorial again and do it n minus 1. The value will be now n minus 1. This function is written by the following of the syntaxes of C language, right? Although the concept of recursion is same in all the languages. So this is the function that we are using, right? So what happens to execute this function? अगर ये function memory में store होने जा रहा है, suppose करो अब ये recursive function है, तो इसके लिए क्या use करोगे? Stack use करोगे. Fine. Now the first call of the function, suppose I wish to calculate factorial of 4. For the first call, my function will be factorial 4. Will go to the stack. Fine. The pointer of the stack, the top will be incremented by 1. Now my function will become, the statement will become n into, and the function call will be 3, right? Now the top pointer will increment by 1. So the statement will be n into, and function call is n minus 1, that is 2. Now again top pointer will increment it to 1. So statement is n into, and then call of the function. Call of the function is fact1. Now what will happen? This is your top. Now from this place, the value is going to return. From this place, the value is going to return. In what way? Because the value of n has become now 1. So the function will return 1. Function will return 1. So the statement of this particular top has become 1, right? Now sorry for the disturbance. So the statement of this will become 2 into 1 because the last n was 2 and the factorial 1 has returned 1. So the statement will become 2 into 1 and the value will be returned as 2 from factorial n into factorial 1. Now this 2 has returned as value into this. So this will become n into 2. What is the value of n from the last function? 3. So the statement will become 3 into 2 and this particular statement will return 6. Now what is the value of factorial 3? Value of factorial 3 is 6 and the value of n is 4. Now what is the value? 24. So basically your factorial 4 will return you 24. This is the final value that you'll get in the stack. So in these cases, the storage area which is used for the execution is stack. So this is the example of the recursion where generally we apply stack, right? Now look at the diagram so that you can understand this concept very easily. So the lowest area, from the lowest area of the memory, code is stored. After that, static and global variable is stored, and obviously these two areas, the requirement of these two area of the memory is known at the compile time. After that, there is an area heap, and then there is an area stack, right? These two area does not have any specific boundary between them. Like code is a fixed area, static is a fixed area, but heap and stack is not a fixed area. There is no as such hard boundary between them. So if what happens in these two what happens in between these two area, it grows and shrinks according to the requirement. Suppose in your program, if you are allocating memory dynamically more, then heap area will grow. And if you're not using a stack, or you have used a stack in a very limited way, so this area will take the limited memory and the heap will grow. Fine. So it will occupy this free memory area. But in case your dynamic memory allocation is less, but you are using a stack more in the logic, so the stack area will grow towards the free memory area. So according to the requirement, according to the logic of the program, the storage allocation happens between heap and stack. Now the question is that suppose both areas are growing and the memory is covered, the free memory is finished. So what will happen? The program will give you memory error, right? That RAM is not available, not enough memory is available. This kind of errors you will get in the storage allocation, in the form of a storage allocation error. Now, the second element that we require for the runtime environment is called as activation record. Activation record. Now, what is the activation? First of all, before starting the activation record, we should discuss about the activation. So activation is what? Activation is execution of a procedure in program is known as activation of a procedure. What is it? Execution of a procedure in program is known as activation of a procedure, right? We also called it as process. So basically the executing state of a process is called as process, or you can call it as activation of the procedure or function, right? So whenever any function is called, we require some block of the memory which is called as activation record. Fine. The second point is whenever any function is called, we require some block of the memory which is called as activation record, right? Now this activation record contains several values. It contains the return address of the function, it contains return value of the function, it contains local variable used inside the function, it contains parameter passed into the function. So these informations are stored inside the activation record. Fine. Now for every call of a function, we have a separate activation record. This needs to be remembered. For example, we discussed about the factorial 4. How many times your function has been called? Factorial 4, factorial 3, factorial 2, factorial 1. So how many times your activation will be created? 4 times. 4 times activation will be created, and obviously return value will be different, return address will be different, parameters will be different, and other things can also be different in the activation record, right? So one more thing, although parameter values, return values, all these things we know at the time of run only, at the time of execution only, but still we have to allocate some area so that when the value is calculated or when the value is passed, we can store that particular value into that particular area. We cannot store it randomly. So it is very important that you should fix a particular area where parameters are going to be stored whenever it will be passed, where the return value will come, where the program will return to the main program. So which means return address. What should be the return address? We need to store all these values into the memory, and for that we prepare the memory area, right? So these all areas are available in the activation record. Now the most important thing which comes in for the activation record, where should we store the activation record in the memory? This is the important point, right? Where can we store the activation record into the memory? So there are three possibilities. You can store the activation record in the static area. You can store the activation record in the stack area, which are the most common and used options. And apart from that, there is one exception. The third option, you can store the stack, you can store the activation record into the heap area also, right? So these are the three possibilities, and obviously these three possibilities of the location depends on the compiler developer, where he wants to store the activation record. Now we'll see one by one what is the problems we will have in the particular location of the activation record, right? So first possibility where we can store the activation record is the static area. If we store the activation record into the static area, what will happen, right? Okay, so first of all, you should know that the static area in which the activation record is being created, which the language example is Fortran. In the Fortran, basically static area was created, activation record was created into the static area, right? So what will happen? We know that static area is a fixed area, and in a static area, first of all, you have to store static variable. Then you are storing global variable. These two things need to be stored into the static area only, right? After that, we store the activation record of a function into the static area. So first thing, this area is fixed, and we should know prior hand what is the size of the function and what are the functions going to be invoked into the program. Now let's take one example. Suppose I have written a program in which I have called a P1 function. So one activation record is required for the P1 function. Then I have called P2 function. Then one activation record is required for the P2 function, right? So which means the static area will contain a static variable. It will contain global variable, then two activation records, right? Now, what will happen? The activation record, inside the activation record, all the information of the functions will be stored. So it will store actual parameters, it will store local variables, it will store return value, it will store return address. These things will be stored into the activation record of the function, right? But what is the problem if you are storing the activation record into the static area? First thing, you can store only single activation of the function. Single activation of the function. What is the meaning of that? What is the meaning of that? If your function is called only one time, then you can store the activation record into the static area. But if your function is calling itself again and again, which means you are using recursion, then this cannot be stored into the static area. Your static area will get fail, right? So the recursion is not possible in the static area. Why? Because we know that for single function, for every function, one activation record is required. We have a fixed memory, right? If you are creating a factorial program in the recursion form, what will happen? It will call itself again and again till your function doesn't reach to the value 1, which means how many activation record I require. Suppose if I wish to calculate factorial 4, so I require 4 activation record, but area is fixed. I have no idea how many times my function is going to call in the memory. Suppose first time I have called factorial 3, which means 3 times my function will be called, dynamic allocation. Second time I have called factorial 4, which means 4 times my function is going to be called, which means 4 activation record is required, which is again dynamic allocation. So dynamic allocation is not possible in case of a static area, because we have to tell the compiler that how much activation record is going to be created. And if you're using a recursion, then it is dynamic allocation. You will know how many times your activation record will be created at the runtime only. So this concept is not possible. So single activation of the function is possible in the static area. Second thing, the memory requirement, the number of activation records to be created, it should be known at the compile time only. So memory requirement, or I should say the number of activation record should be known at the compile time only. Okay. So if the number of activation records are not known at the compile time, your activation record in the static area will get failed. Fine. Okay. So these are the disadvantages of the static area if you are putting the activation record into the static area. Now the next possibility to put the activation record is the stack area, right? You can put the activation record into the stack area. Fine. So we are putting the activation record into the stack area. Now, as we know that stack can have free memory area. The area is not fixed. It can grow, it can shrink. So example languages where we use the activation record, we store the activation record into the stack area. C, most common languages, C++, we store in Java. These languages you have already studied. So these languages uses the memory storage area, stack area, to store the activation record, right? So what are the possibilities? First thing, you have the fixed content of activation record, but how many activation records is going to be generated need not to be known priorly at the compile time. Fine. Which means what is going to be stored into the activation record, that you know, that we have already discussed: return value, parameter value, local variable, all these things we know at the compile time. These areas will be created in the activation record, but how many activation records you require, it will be decided at the runtime. Fine. So what will happen whenever, कितने activation record बनाएंगे आप? Whenever your function will be called, function is invoked, one activation record will be created. One activation record will be created, right? So basically, if you are using recursion and you have passed, say, factorial recursion, and you have passed factorial 3 for the first time, so 3 activation record will be created. And on the top, which record will be there? Factorial 1. This you need to remember. Suppose in the next time you have created, you have called a function factorial 10. So how many activation records are going to be created? 10 records, right? And the top function will be factorial 1. And the last and first out concept will be used. Factorial 1 will be removed. If it is calculated, the value will be substituted to the factorial 2, and so on. In this way, your factorial 10 will be calculated, or your factorial 3 will be calculated, right? The only problem which can occur in this technique is, if it require lots of space. So sometimes if your memory is not sufficient, if your RAM is not sufficient, it can give you stack overflow error. As I've already told you that the same area is shared by the heap and stack, right? So if in your logic you have used dynamic memory allocation more, so heap will grow. And if you have used stack concept more, so stack will grow. And if both areas growing or one area is growing and the memory space is over, so in that case you can have memory overflow error. This is the only problem that we have in the stack in the allocation of the memory for the activation record in the stack. So when you will get these kind of problems, what can be the solution and where you will find these kind of problems? Let's take one example. Suppose in a function, I have created an array A, and which is of, suppose karo, 10,000 elements, right? And I'm calling this particular function recursively approximate 100 times. I'm calling this function recursively approximate 100 times. Say this is the n that I'm passing, and suppose I'm calling this function again and again, and the value of n starts with 100 or 1000 or something like that, right? We know that this particular array will behave as a local variable. This is a local variable, right? Which means I have to store this array into the activation record because it is a local variable. So the local variable itself, if I assume that one variable is taking, one integer is taking 2 bytes, which means for this particular array, in one activation record, you have to allocate 10,000 into 2 memory, 2 bytes, right? And if you're calling a function 100 times or 1000 times, how many activation record is going to be created? If you're calling it for 100 times, 100 activation records will be created, and every activation record will separately allocate this memory. So obviously in this case, you can find the error if your RAM is not sufficient, or if your stack area memory is not sufficient, you can find the stack overflow error. This is the error that you will find. So what can be the logic solution in that? If it is not required to declare this particular array as a local variable, then declare it as a global array, right? So that the array is allocated only once. In every activation record, you can use that array, which is a global array. So it won't be reallocated again into the activation record. So these are the solutions that we as a programmer can develop, and we can find out the solution of these problems, right? But there are still certain cases where we have to allocate array or these kind of memory in the local area only. For that, we do not have any solution except to increase the memory area. Fine. Now there is one exception. Where are we going to create the heap? Where are we when we are going to create the activation record inside the heap? So basically, there are some exception language. Example, Lisp, where the whole function gets called and the whole function gets returned as a value, right? Which means the function is used, calling and return is in the form of dynamic memory allocation. So where we use the heap area for the allocation of the activation record, right? Otherwise, generally, most of the languages prefer to store the activation record in the stack area. Fine. So we have already discussed three storage possibilities where we can store the activation record. First, you can store into the static area. Disadvantage is that your memory requirement or the number of activation records needs to be created should be known at the prior hand at the compile time. If it is not known, you can't store the activation record into the static area, which means recursion is not possible, right? Second possibility to store the activation record into the stack area, where the memory requirement is not fixed and it shouldn't be known at the compile time, which means your number of records, the number of activation records can be as many as possible. So which means you can apply the concept of recursion. And we already know that whenever we invoke we invoke the function, one activation record will be created for that particular invocation. So for the recursion, जितनी बार भी आप फंक्शन को कॉल करोगे उतने एक्टिवेशन रिकॉर्ड स्टैक के अंदर बनेंगे. Sometimes if your memory is not enough, so we get the error stack overflow, and I've gave you solution of that error that we can solve with the help of program logic, right? And in some cases we can't find the solution, so there is only one solution to increase the memory. Heap area में rarely we do not prefer to store the activation record, but in some language like Lisp, we have to store the activation record into the heap only, because the whole language, the whole function works in the logic of dynamic memory allocation and deallocation, right? One disadvantage of the activation record stored in the heap area is because we do not have the sequential memory allocation in the heap, right? So suppose you have called a function, so one activation record is stored here, and second activation record suppose करो यहाँ पर store हो गया, third activation record suppose करो यहाँ पर store हो गया, because it finds that this is the free area. Now what will happen, the third activation record has been called, which means the memory is deallocated. Now this area is free. What will happen? We have to apply some memory memory free allocation technique that we know, that's fragmentation and defragmentation errors. So fragmentation का मतलब बीच बीच में holes बन गए हैं. आपने ऑपरेटिंग सिस्टम में पढ़ा है, बीच बीच में क्या बन जाते हैं, होल्स बन जाते हैं, और वो एरिया फिर आप यूज नहीं कर सकते जब तक उतना बड़ा कोई प्रोसेस आपको नहीं मिलता है, राइट? तो उसके लिए आप कुछ टेक्निक्स यूज करते हैं, बेस्ट फिट, फर्स्ट फिट, वर्स्ट फिट. So these kind of techniques we have to apply for allocation and deallocation, or to occupy the free memory area, right? These techniques you can study in the subject of operating system. You can revise from the operating system also. So these kind of problems sometimes created in the heap area, because the memory allocation is not sequential in the heap area. Fine. So the last topic in this series is which is the part of runtime environment only, processor register. Processor registers, right? Now there are certain fixed registers in the processor that we use for the for handling the runtime environment. So these are also the part of runtime environment. Generally these registers are used to store temporary values. Now what are the temporary values? Or the local variable values at the time of execution, right? Or the spatial information. Spatial information is stored into the processor register. So what is the temporary values? Suppose I have created a 3 address record, and the statement is A is equal to B plus C into D. So T1 is a temporary variable which will be created to solve the expression C into D, right? So T1 will be stored into the processor register. Then this T1, this A is equal to, I can write T1 plus B, right? So for these two, for solving this particular expression, I require a temporary variable T1. And for this T1, your processor register is going to be used. Now the second use of the processor register, we have a special processor register that is called as program counter. This you have studied in CO and operating system also. This processor register is used to store the address of the next statement to be executed. Address of the next statement to be executed, right? Now the third spatial register is a stack pointer. Stack pointer. This basically points the stack this basically points the top of the stack. which is a memory location which is pointing, which is right now top of the stack. So this is contained by the stack pointer. Right now we have a frame pointer. Frame pointer. What is the function of the frame pointer? It points to the current activation record. Activation record. Fine. Like you have called function P1, then you have called a function P2. After this, you have called a function P2, then you have called a function P3. So what will be your current activation record? P3, the activation record of P3. So the frame pointer will point to the current activation record, right? Then we have the argument pointer. Argument pointer. So argument pointer basically points the area of the activation record received for the arguments. जहां पर आपके जो arguments हैं वो वहां पर return होकर के आने वाले हैं. Record for received arguments, right? Acha, one more thing, it depends on the language to language or operating system to operating system which processor register is going to be created. So sometimes there are fixed registers and stack pointer, program counter, stack pointer, frame counter and argument pointer are not there by name. So the existing registers needs to be converted to perform the role of a stack pointer, frame pointer and argument pointer. Generally, we have program counter as a fixed processor register in all the processors, right? So we need not to create it again, but generally stack pointer, frame pointer and argument pointers are not present in the processors or in the languages. So we have to create it. We have to take some existing registers and convert the function of those registers, or temporarily we use those registers to behave it as a program counter, argument pointer and stack pointer, right? So this is all about the runtime environment. So we'll take one revision. What is the runtime environment? The runtime environment is basically the environment that is required by a program in the memory for the at the time